WPHAT. You're listening to the #1 health and wellness podcast, the place where health and consciousness connect. Perfectly healthy and tone radio with your host, Darren McDuffie. And now, prepare to get fat. What's up, peeps, and welcome back to another episode of Perfectly Healthy and Tone Radio. I'm your show host, Darren McDuffie, alias Fat Man, because I help you become perfectly healthy and toned and conscious, of course. This episode today is being brought to you by perfectlyhealthyandtone.com. Today's episode is with Stephan Guyenet on his book, The Hungry Brain. But before I get into a little bit more details about that, wanted to give you a reminder of the preceding episode I did with Michelle Brown on her book, Energy Reset. One thing that stuck out with this podcast that I did with Michelle previously was her quote as referring to the thyroid as the canary in the coal mine. So if you're out there and you want to listen more about the thyroid, about why you might be fatigued, and also if you are male or female, you want to know what's in your cosmetic products. So Michelle did a thorough job of kind of guiding us through that to gather those factors or why we might be suffering from fatigue in our society today. So I highly recommend her episode, and do please go back and listen to it. Today's episode is again with Stephan Guyenet on his book, The Hungry Brain. If you've been in the society for any amount of time, you know that some people have an issue when it comes to shedding weight. But what you don't know is that this whole thing of calories in, calories out may not be working because our brain is hardwired to seek out calories. Isn't that something? So we get into that a little bit more, Stephan and I, about the brain and what you need to do in order to trick the brain into finally helping you shed that weight. So without further ado, let me give you Stephan's bio. Let's get into Stephan Guyenet's bio. Stephan Guyenet is an obesity researcher and health writer whose work ties together neuroscience, physiology, evolutionary biology, and nutrition to offer explanations and solutions for our global weight problem. He received a BS in biochemistry at the University of Virginia and a PhD in neurobiology at the University of Washington. He is the author of the popular health website Whole Health Source and is a frequent speaker on topics of obesity, metabolism, and nutrition. Here's what you're going to learn on the upcoming podcast, The Hungry Brain with Stephan Guyenet. Is the calorie in, calorie out model the best way to shed weight? If you've been on this earth for any amount of time, you know that the thing that people tell you how to shed weight is to eat less and burn more calories. Stephan's going to explain to us why this ends up backfiring on us. How does the brain fight against fat loss? The brain is hardwired to keep calories, and Stephan talks about that. What does the brain care about in food? You'll be surprised. Why does the brain value fat, sugar, and starch? Again, we are hardwired to seek out these things within our food. What role does dopamine play in reinforcing eating behavior? If you're not familiar with dopamine, pay attention. And the last thing is, what role did our ancestors play in our present day battle with obesity? We go into detail about how our ancestors played such a great role in why we're seeking out food on a constant basis. So that's what you're going to learn. Get ready for the podcast. Welcome back to another episode of Perfectly Healthy and Tone Radio. And today I have a special guest with me. His name is Stephan Guyenet. Stephan, welcome to Perfectly Healthy and Tone Radio. How are you tonight?
I'm good. Thanks for inviting me, Darren.
Thanks for coming on. I read your book, The Hungry Brain, and really reached out to my assistant to have you on the show. One thing I want to say is your book is really thorough. And I have never read a book that is so thorough, but I understand that you're a PhD and part of what you do is based upon research. But one thing I like to ask people when they come on the show is my obligatory question. And that question is, how did they start getting into health?
Yeah, so, I think there are certain things that each of us is just kind of inclined towards from a young age. And health and fitness is one of the things that I was inclined toward from a young age, and also science. I was always really interested in understanding how the natural world works, and when I was a kid, I literally used to read science textbooks for fun. So like anatomy and physics and chemistry, whatever I could get my hands on. And not to say that was the only thing I did, but that was one of the things I did. And yeah, so I was always fascinated with neuroscience in particular because the brain is really one of the greatest remaining scientific frontiers, because the brain is probably the most complex object in the known universe. And so there's a lot about the brain we still don't know. And so I kind of took a meandering path through science that led me to get my PhD in neuroscience, BS in biochemistry. And then eventually I decided I wanted to merge my two interests of health and fitness and neuroscience. And really obvious way to do that is to study the neuroscience of eating behavior and obesity. And so that's what I did for my postdoc at the University of Washington, working with Mike Schwartz, who's a longtime obesity researcher. He's done some of the foundational work in that field. And I realized a few things pretty quickly. And one of them is that we were studying the right organ, because if you think about it, I mean, the brain is the organ that generates behavior. So if you think that what you eat is important, if you think that how much you eat is important, if you think that how you use your body is important, if you think that any of your behaviors are important to your body fatness and your health, then you think the brain is important. So I think understanding that is really important. And also another thing that most people don't understand is that the brain regulates physiology. So it actually regulates your body fatness, it regulates your body temperature, it regulates your appetite, regulates all of these things that relate to all of your body's processes. And so I guess what I would say is that at some point I accumulated enough knowledge in that field and accumulated enough perspective on it that I felt like I had a really important story to tell. And another reason I felt that way is because I was learning about all these things that were well supported and well accepted within the scientific community, within my field, but most people have no idea of. Like, people were just not writing books about this stuff. They were not translating these incredible insights, what I view to be incredible insights from the scientific literature, for a more general audience. And so I think that is why you found my book to be so thorough and to be different than other books, because I really tried to take a broad swath of research within the field of obesity neuroscience and eating behavior and tried to communicate it for a general audience, including a lot of information that had never been communicated to a general audience before. So that's kind of how I got to where I am today.
And you yourself, I'm going to imagine that you exercise regularly, and you kind of, from the book I got, the inkling that you are one of those people who are really using this stuff yourself, because a lot of times you'll interview people and they're not really using the stuff, but it seems like you're one of those persons who's really using your research to kind of live a better life.
Yeah, I do use it extensively. I just got back from a run, in fact. So yeah, as far as physical activity is concerned, I think physical activity is pretty much essential for optimal health, physical and mental performance, and healthy aging. So I think if you want to live your best life and your longest life, you have to be doing physical activity, and hopefully a variety of different things that maintain your heart and your lungs and your muscles and bones. But of course, physical activity is not all there is to it. And by the way, I want to be really clear that I'm not a drill sergeant with myself. So, I'll eat junk food sometimes. I'll eat pizza sometimes. I'll have candy. I'll have ice cream. Like, I eat occasionally all of the foods that I think are fattening and unhealthy. I eat all of that stuff. I just don't do it very often. It's not a regular part of my diet. So what 90+% of my diet is food that I cook at home from single ingredients, I should say, that is a varied, nutrient dense, lower calorie density, omnivorous diet.
So you're human, and I like to say that I'm human too, because I think when people who are in the nutrition field, or people like yourself who are researching things that have to do with the nutrition field, a lot of times people don't view us as human, because they're thinking that we never eat pizza. I just had a gluten-free cookie. So before I got on the podcast. So that's a good thing that you're letting people know that you are human. Now, one of the things that I wanted to ask you from the very start is, and I think you may have mentioned this, but I wanted you to elaborate. Back in my past, I had a boot camp, and I knew that there were things that I didn't know because I would always throw exercise at people who were participating in that boot camp. And for some reason, these people, these women that I was working with, they weren't losing any weight. So I think sometimes what happens when you see these books on dieting, when you see things on TV, that people make the equation of losing weight simply as a calorie in, calorie out equation. Your book made that very clear that that's not the case. What all goes into really sitting down and saying, hey, I want to lose weight? What really goes into that?
Yeah, so I want to start off by talking a little bit about the calories in, calories out concept, that idea, because there are different things that people can mean when they say that. And if the idea is that your level of body fatness is determined by the number of calories entering your body versus the number leaving, then that is actually correct and consistent with my book, and it's very well supported. It's basically arithmetic. But on the other hand, what a lot of other people mean when they say that, and what I think you mean, and the way that it's relevant in the way that you're describing my book, is when you start to say, well, all you need to do is just consciously control your calorie intake and consciously ramp up your exercise, and then you'll be good. And I think that's where people start to run into problems. And here's what it boils down to, I think, is that kind of way of thinking about it assumes that the only thing controlling our body fatness is our conscious, reasonable decisions and willpower. So we can just kind of, make an Excel spreadsheet with all the calories in and calories out and then follow it and lose fat and there's no problem. It doesn't acknowledge the fact that eating behavior and body fatness are regulated by the brain. And even though it is true that if you eat fewer calories or burn more calories, you will lose body fat, the problem is that it's not easy to do that. So when you start burning more calories, the typical response from these regulatory systems is to get you to start eating more calories too. So there's a system that's trying to maintain some kind of balance inside your body, and that system doesn't really want you to lose fat. That's really a big part of the issue, and that's really the main thing that keeps us from losing weight, or at least one of two main things, is the fact that your brain fights against fat loss. And so if you don't understand that, and you don't recognize that there are non-conscious circuits in your brain, just like there are circuits that regulate your heart beat and your breathing and your digestion and all these things outside of your conscious awareness, there are circuits that are regulating your body fatness and your eating behavior, and those circuits kind of have a mind of their own. It doesn't mean we can't influence them at all, but they have a mind of their own. And so if we just come into it and try to kind of like exert our will to eat less, to have portion control, and to just move our bodies more in that kind of way, without acknowledging and working with those systems that are having an important impact on all this, then we're going to run into serious resistance. And that resistance is very persuasive. It comes in the form of hunger. It comes in the form of cravings. It comes in the form of reduced metabolic rate, coldness and sluggishness that makes you not want to exercise. And so and it wins in the end. For most people, it wins. And we know this, that when you just ask people to eat less, or you just get them to exercise more, there's a pretty limited amount of fat loss you can get out of that. I'm not saying you can't lose fat that way. You can. But for the average person implementing it in the average way, they just aren't going to be able to fight themselves on a continual basis. They're not going to be able to fight their hunger. They're not going to be able to fight their cravings on an ongoing basis in order to create and maintain the level of fat loss that they generally want. And so I think you need a different system. You need something that acknowledges these non-conscious circuits that are making things difficult for us, and you need a way to work with those circuits.
In your book, you discuss about the brain seeking out calorie-dense foods and making us want to eat. Is the brain serving its own issue to keep the brain alive, or is it serving its issue of keeping the body alive? Because I remember in the book you said the brain uses, and you can tell me if I'm right or wrong. I don't remember the exact verbiage, but the brain uses 1/5 of the energy stores, I think it was. So my question again is the brain serving its own issue or just trying to keep the body alive by motivating us to go out and eat?
Well, I think it's doing both. And yeah, the brain makes up about 2 to 3% of our body weight, but it eats up 20 to 25% of our total metabolic rate. So it's burning 20 to 25% of the calories that we're taking in. And yeah, it's a huge energy hog. And the reason that natural selection permits it to be such an energy hog is because it's incredibly important for us. But I think it's really doing both. I mean, the brain is regulating how much fat you're carrying on your body, but it's also regulating to some degree the amount of glucose that you have in your blood in order to maintain its own fuel supply. And so the brain, under normal circumstances for the average person, uses almost exclusively glucose as its fuel. So that's the blood sugar. The sugar in your blood is what your brain uses, as opposed to fat in your blood. Most of your tissues can use sugar or fat. Your brain only uses sugar under normal circumstances for the average person. And yeah, and it has ways of protecting that. So the brain is really sensitive. The reason the brain's such an energy hog is because all those brain cells are having to constantly fight to maintain their signaling capacity. They have to pump ions across the cell membrane constantly, and that's really requires a lot of energy. And if they can't do that, then you're going to lose function and you're going to die. So it's really important to preserve the brain. And so if your blood glucose starts to drop too low, like if you have diabetes and you inject too much insulin, for example, you have a very swift and powerful response from the brain via your endocrine glands and other things that brings that glucose back up. So you get real hungry, you get hormones released that release glucose from your liver, other stuff like that. So the brain is really doing both. It's protecting itself and it's protecting the energy status of the body. But I think under normal circumstances, it's acting mostly to preserve the energy status of the body as a whole.
In your book, it says, in 1960, 1 out of 7 were obese. Then by 2000, 1 out of 3. What I did was I went in and I did some research, and I wanted to see when the first TV dinner was actually introduced. That first TV dinner was actually introduced in 1950. I realized that our food started changing because I can remember when McDonald's was the highlight of my Friday. Like I would ask my grandmother, hey, can we go to McDonald's? And we would go to McDonald's, but we would only go to McDonald's maybe once a month, if that. Now you're seeing people who are eating fast food every day of the week. Sometimes, all days of the week, 7 days a week. So with that food changing, I'm wondering if, because we're eating all of these calories and we're eating a lot of empty calories, a lot of breads, a lot of things that contain sugar, but we're not getting the real calorie dense foods. What's really happened is that kind of propelling this instance where we're driving this obesity because we're eating these foods that are containing, they might be foods that contain a lot of calories, but they contain what I might call empty calories. Is that driving the obesity?
Yeah. So this is, if I'm understanding correctly, you're saying, correct me if I'm wrong here, you're saying, is it that we are eating to try to hit our micronutrient needs, like our vitamin and mineral needs, but we have to keep eating because there's not enough of that in our food? Exactly. Yeah. So I don't think so, actually. And I'll lay out why I don't think so. I think that, okay, so there are certain things that the brain cares about in food instinctively, intuitively, and certain things that the brain is wired to care about a lot, and other things that the brain doesn't seem to care about. And the reason we know this is because certain food properties can do something called reinforcement. So you can basically train a rat or a mouse to do certain things by giving them certain types of nutrients. And actually you can infuse them directly into the digestive tract, and you can train them to like one thing over another, for example. And so the brain is set up to prefer and seek certain specific types of nutrients and to learn what foods contain them. And those nutrients are things like sugar and starch and fat and salt and glutamate, which is that meaty umami flavor that's in MSG or bone broth or cooked meat. And I don't know if I think I said fat, and then protein also. And so those things are hardwired motivational factors to the brain is a good way to think about it. But vitamins and minerals are not. So the brain, you can't reinforce behaviors with thiamine. You can't reinforce behaviors with magnesium. Like we can't even taste these things in food. Like you can taste fat. You can taste, or, at least by its texture, you can taste sugar for sure. You can taste glutamate. You can taste salt. By the way, salt's the one exception. That's actually an essential mineral, sodium and chloride. But all these other things you can't taste. Natural selection did not wire motivational systems attached to those things into our brain. And the reason I think this is that our distant ancestors, they hunted and foraged for their food. And that food, the only available option for them was to eat a whole food omnivorous diet. Like that was what they all did. And so if you're eating that kind of diet, if you're getting enough calories to fuel your body, you're meeting all of your micronutrient needs, because those are very nutrient-dense foods. All of those wild plants and animals that they're eating are very nutrient dense. So if you're hitting your calorie targets, you're probably hitting all your micronutrient targets. And this is supported by the fact that hunter-gatherers tend to be very well nourished. And so I think there just wasn't a need to wire that stuff in our brains, because it all came passively as part of the diet. Another piece of evidence I'll say is that if you make animals deficient in a nutrient, they don't actually eat more, they eat less and they lose weight. And then when you give them the nutrient back, they gain the weight back and they eat more again. And also, if you look back at the American diet a century ago, if you go back to the time before we discovered vitamins, before we knew what vitamins were, about a century ago or a little more, there were lots of nutrient deficiencies all over the place. Like in the United States, there was iodine deficiency goiter in the Midwest. There was pellagra in the South. There was rickets all over the place. There was scurvy. There was all kinds of these nutrient deficiencies, and yet people were a lot leaner back then. So I don't think it's nutrient. I don't think that the brain is really trying to get micronutrients. I think it's a lot simpler than that. I think the brain just really likes these calorie-dense foods that have a lot of these properties that it's hardwired to seek, the fat and the sugar and the starch and stuff. The brain implicitly values those things. We know that because we enjoy them and we're motivated to eat them. And when the brain implicitly values something, it finds ways to get you to have more of it. And so basically, we just really like those foods and we overeat them. And it's probably more complicated than that, but I think that's a big part of it.
Is that when you said when the brain wants us to eat more of that? I'm getting the fact that there's a neurotransmitter out there you talk about in the book called dopamine. When we're eating something that we really enjoy, is that when the dopamine is released and kind of reinforces what we're eating to tell us, hey, you know what? I like this cookie. Like I'm thinking about another cookie now right after we get off the podcast. So for me, that cookie it was a good cookie, but something in my brain tells me, I need to get another one of those cookies. Is that the dopamine that kind of reinforces that?
Yeah, almost certainly. I mean, yeah, so dopamine is a key chemical in reinforcement. So dopamine is intimately involved in deciding what our motivations and our cravings are. So when you have that kind of visceral gut motivation, like a craving for a food, for example, or it can be for many other things. It could be craving for sex, a craving for warmth, or whatever your really like basic gut level motivation is, that probably involves dopamine. And basically the way it works is that when you eat a food that contains certain nutrients, those ones I was talking about, like fat and starch and sugar, salt, glutamate, protein, that goes into your digestive tract, and there's all these receptors in your small intestine that detect those nutrients, and they tell your brain about what you just ate. And the more of those nutrients are getting detected by those receptors in your small intestine, the more dopamine spikes in your brain. The more dopamine spikes in your brain, the more your brain learns that that is an awesome food. So all the things that your brain took in when you were eating that food, the taste, all the sensory experiences, the taste, the smell, the appearance, who you were with, where you were, what the brand was, all of that stuff gets stamped into your brain by dopamine. And then the next time you encounter that, it's a motivational trigger and your dopamine starts to spike again. So that's why when you walk by a bakery and you smell bread, or you're smelling brownies coming out of the oven, or you're smelling bacon on the stove, or you're smelling all those other foods that are really concentrated in those nutrients, that triggers your motivation, because that sensory cue, the smell of it or the appearance of it or whatever, was previously reinforced by that dopamine release when you ate it. Basically, your brain is saying, oh yeah, I recognize that smell. That smell is associated with this awesome truckload of calories that's about to be delivered, and I'm going to use that to trigger this motivational state to get you to eat that food, because I know that that's really good for you. Because it used to be good for our ancestors to eat those kinds of foods, because they lived in an environment where it was hard to get food, and so they had to be really motivated to get foods, especially the foods that were really concentrated in the nutrients that they needed to fuel themselves. The problem is today we still have those motivations. We still have those really strong drive systems in our brain, but we have too much opportunity to indulge them. And so those drive systems are just too sensitive for the modern environment, and they push us to eat that food too often.
You talk about reinforcement, but is there a fine line, Stephan, between reinforcement and addiction? And one of the things that your book pointed out to me, because, and I might be just like anybody else that's listening to this podcast, that I often connotated food addiction with people who are obese, whereas your book clearly pointed out that people who are skinny like me, or like you and I, can also have a food addiction. But what is that? Is there that fine line between reinforcement and addiction, and where does it come in?
Yeah. So basically, addiction fundamentally is an arbitrary line that we draw on reinforcement. So we basically say, when your motivational drive is stronger, and this is, I'm talking about in broad generalities. I think this is really the essence of addiction. When your motivational drive to engage in a certain behavior is so strong that it starts seriously harming your life, that's when we call it addiction. But it's not any different. It's only different in intensity. It's only different in strength than the normal motivations that all of us experience in our daily lives, and that in many cases are actually good for us. So it's probably good that you feel motivated to like eat an apple. It's probably good that you feel motivated to have sex with your partner, or feel good, motivated to go for a walk or put on a sweater when you're cold. Like there are all these things that are healthy, constructive part of our life that it's good to feel motivated about. The problem is when that motivation becomes excessive, and then it starts to dominate your life. It starts interfering with your social relationships, interfering with your work, interfering with your health, etc. And then that's when we call it addiction. But it's a totally arbitrary distinction. And so food reinforcement, what we've been talking about, how food creates the motivation for you to eat it, that exists on all levels of that spectrum. So certain types of foods, like let's say brownies or ice cream or pizza or whatever the listener's favorite food is, those things are reinforcing and motivating to pretty much everybody, but not everyone. It won't put all of us into the level of motivation that you might call addiction. So, but regardless of whether you call it addiction or not, it makes all of us overeat. So that excessive motivational drive, whether or not it crosses the threshold and you say you're addicted, it makes all of us overeat. It makes all of us eat too much because those foods are too highly motivating. And so, yeah, so basically foods that are really concentrated in these nutrients that spike dopamine in the brain. And by the way, let me take a step back. Everything that's addictive spikes dopamine or stimulates the dopamine pathway in some way. That is so that is so consistent that you could almost call it a part of the definition of addiction. Dopamine is intimately involved in addiction. And so basically with these foods, we know that food spikes dopamine, and that's good. You know, we should be motivated to eat, right? Like we have to eat. We want to be motivated to eat. So evolution wired us to be motivated. But the problem is that the more of these nutrients the brain is looking for, the more concentrated those are in the food, the greater the motivational state those cause in the brain. And so when you have these foods that are expertly designed by the food industry or a chef in a restaurant or even by yourself in your own kitchen to push those buttons in your brain really, really hard, that's going to spike a lot of dopamine. And some people can handle it, some people can't, but most of us probably shouldn't.
You mentioned hunter-gatherers, and I kind of wanted to go back to that. In the book, it talks about, I'm not sure if I'm pronouncing this right, a tribe called Kutava. I don't know if
Kutava.
Kutava,
yeah.
You mentioned that there was a point where they would kill animals and they would eat just about everything and they would overeat. Has the brain developed on the principle of feast and famine? Has that trained our brains to figure out that, hey, we may not have any food, but now food is so abundant. You just walk into a grocery store and you can pick anything on an aisle, or you go to a farmer's market, you can pretty much get anything that you want. Has that feast and famine from the Kutava kind of driven our motivation to eat more at this point in time?
Yeah, I think to some degree that's true. So the anecdote you're talking about was not associated with the Kutava. It was associated with the Aceh and the Hadza.
Oh, okay.
Yeah, because that's all right. I talk about a number of different non-industrial cultures in my book because I think that's really important. I think it's really important to understand how our ancestors live if we want to understand who we are and how we should interact with the world today. And if we want to understand ourselves, like it doesn't make any sense that we overeat and harm ourselves with food and become obese and develop diabetes. It doesn't make any sense, right? The only way that makes sense is if you look back in time and you say, oh, now if we look back, we can see the context in which these traits evolved, and we can see that they actually used to make a lot of sense in the context we used to live in. The problem is that our environment has changed, and now they're not playing well with the environment. But anyway, to get back to your question, yeah, I do think there is a kind of feast and famine thing going on in our evolution and how our brain is wired. If you look at the calorie intake of a hunter-gatherer, it is more variable than ours today. So they didn't store food generally. They didn't keep, most groups were not even keeping food from one day to another. There were some exceptions, but most groups were not keeping food from one day to the next, or very little. And so basically whatever you found on that day was what you ate. And sometimes you found a lot, sometimes you didn't find as much. And they mitigated that by sharing food. So it's not like they would like starve for a week and then find a bunch of food. And I'm not saying that never happened. I'm just saying that wasn't typical. But the variability was much greater than us. Like for us today, like skipping one meal for most people is like completely inconceivable, right? Or like eating half as many calories as you would normally eat in a day is completely inconceivable and would be like really distressing to most people. So, but for a hunter-gatherer, that's pretty normal. And so hunter-gatherers, they have to work for their food, like they're walking miles a day, they're climbing trees, they're sprinting after animals, they're picking berries, they're digging tubers, they're doing all this work to get their food, and they're not always getting as much as they want. They're not always getting the type of food that they would prefer. And so when they have an opportunity, when they encounter an opportunity to get a ton of easily digested, calorie-dense, nutritious foods, they will absolutely stuff their faces on it. And so the anthropologists I spoke with told me anecdotes that are just mind-blowing, like someone sitting down and eating 5 pounds of fatty meat in one sitting.
Wow.
Or 20 to 30 wild oranges that are very similar in size and sweetness to the ones that we get in our grocery stores. And I'm saving the best for last, drinking 1.5 liters of straight honey.
Oh my God.
Yeah. So that's like 1/3 of a gallon of honey, just chugging it. I mean, can you believe that?
But these tribes, they were never overweight though.
Yeah, exactly. So exactly. And so this is just it, is that these periods of overeating were how they made up for these kind of chronic shortfalls. And you can see that in their body composition, because they tend to be lean, they tend to be muscular, or not like muscular like built, but they had a good amount of muscle. And so I mean, this is basically how they maintained enough energy intake to thrive and survive and bear children in a difficult environment. So they needed that those periods of overeating and gorging, of complete gluttony, were actually good for them. That was a positive, beneficial behavior that helped them survive and thrive and bear children. And so I think my belief, or my speculation, is that is deeply wired into the human brain. We're deeply wired to take advantage of situations where we can get a lot of calories that the brain prefers. And again, the brain prefers things that have high concentrations of these nutrients I talked about, the fat and the sugar and the salt, starch and the glutamate and the protein. And so the brain is always on the lookout for these opportunities to make up for chronic shortfalls. But problem is, we don't have a chronic shortfall anymore, and these opportunities happen every day now. And so I think one other point I want to make really briefly is that this behavior of gorging is not stigmatized in hunter-gatherer cultures. There's not people wagging their fingers at you or telling you you're going to hurt yourself or you shouldn't be so greedy. It was socially acceptable behavior. It was viewed as a positive, normal thing to do, to stuff your face with as much food as possible when you had the chance to do so. And so I think how that's changed now is we still have these urges that are pushing us to overeat that we inherited from our ancestors because they were selected for by natural selection. But today we have to try to fight those, where every day we're having to try to fight those urges to overeat by stigmatizing it and by using our willpower and stuff. But it's not so easy to fight against those urges all the time.
Stephan, what is your, because this just came to me, this whole feast and famine thing of hunter-gatherers, it seems like to me that they were doing a natural type of fasting. And there's a lot of information coming about intermittent fasting now. So I don't know how much you know about that, but it seems to me like the culture that we have now can benefit from this intermittent fasting, because we have food around us all the time. Anytime you go to a social engagement, there's food. Anytime you go to a convenience store, there's food. You go to a grocery store, there's food. So food is around us all the time. Whereas back then there was no food. So they could gorge, they could just stuff their faces, but then they had that natural fasting state when they weren't getting food as readily. But I just wanted to get your thoughts on fasting, and is that a fair assumption to make?
Yeah, I mean, I think what they had was energy variability. So they had variability in their energy intake. And so sometimes they would be losing energy because they're burning through it and not taking any in. And other times they would be taking a lot in and not burning so much. And so there was a lot more variability. And And yeah, that may be something about their lifestyle that was healthy and perhaps is, a kind of basic element that benefits our physiology. I think the evidence in humans that fasting is beneficial is, in my view, not really that well developed yet. I'm not an expert on this, so I'll try not to say anything stupid, but
No, that's okay.
if for what I know, it's not really that well developed yet. But I think there are at least reasonable reasons to speculate that it might be good for us. I mean, you do see that when people fast, people or animals, you see upregulation of certain types of protective and house cleaning responses. So your cells start to kind of digest and recycle itself and get rid of the old musty corners and refresh them with new ones. And so, yeah, and then I honestly think that a lot of the diseases that we suffer from today, the cardiovascular diseases and the diabetes and many, including some cancers and many of the other ailments that we have that are not related to infectious diseases, I think the primary driver of those things is just that we're taking in too many calories versus the amount that we're expending. So excess calorie intake, excess body fatness, I think are really key drivers and possibly the number one driver of this chronic disease that we're experiencing at unprecedented levels today. And I'm not saying that's the only thing at all, but I think it's a really key driver. And so I think anything you can do to kind of reduce that energy excess, or at least temporarily relieve your body of that energy excess, I think is, for most people, is going to be helpful. And I think fasting is one way to do that.
You mentioned in the book as well, and I had to laugh when I was reading this chapter because I know I'm guilty of this, because I don't go to buffets anymore because I know I'm more likely to overeat. But one of the things I noticed when I did go to a buffet was because of the food variety, I would eat more. And you talk about that. You talk about the fact that when we have more variety, we tend to eat more food. Why is that?
Yeah, that's right. And it's actually a really big effect. I mean, you see it in humans, you see it in animals. We will eat a lot more. As most people listening, I think, will recognize that when they go to a buffet, certainly this happens to me, most people will eat a lot more food than normal and just end up being stuffed. And there's actually a really well-characterized phenomenon that explains this, and is called sensory-specific satiety. So basically, when we're eating food, we become satiated or full or satisfied on specific types of food, but that doesn't necessarily mean that we are satiated of all types of food. So if you eat something that has a particular flavor profile, like let's say you're eating a piece of steak, you will become pretty quickly full on that steak, and you're not going to want to eat any more steak. And if the steak is all you have, you're just going to feel full and you're done with your meal and you're fine. You're not hungry anymore. If you add a salad, but let's say you ate your steak and then the salad comes out, or let's say a piece of bread, a roll comes out. Well, okay, you might have been full on the steak. You might have been full if that steak was all you had, but now you're not full anymore. You're willing to eat more of that roll. So now let's say you have something else come out. You have some deep fried vegetable or something. Now you're going to be able to eat that. Now you have a slice of cake come out. Now you're going to be able to eat that. Different dessert, you're going to be able to eat that. As long as they have different sensory properties, as long as they taste different, you have essentially, you can think about it as having different stomachs, basically, for different types of foods. And this is really well established in the research literature. And so if you are in a situation where there's a lot of different foods that each have a different flavor and texture profile, each one is a different experience, then you're going to end up eating a lot more total food before you reach that point of fullness than if you only had one or two or a few different types of unique foods. And so if you go to a buffet and you don't want to overeat, you can just decide, well, I'm going to select these 3 items and that's all I'm going to eat. You select 3 things that make up a healthy meal, maybe some meat or beans, some vegetables, piece of fruit, or whatever you want to have, potatoes maybe. You just stick to those 3 things. You can actually, not only will you eat fewer calories, but you will actually feel perfectly full. You'll feel perfectly full and perfectly satisfied after having eaten many fewer calories than you would have if you put a lot of different things on your plate.
Yeah, that came into play for me this weekend. I went to see Infinity Wars. I don't know if you've seen that or you're a superhero fan, but I am. And I had just eaten maybe about an hour before getting into the movie. And here I am sitting there eating these gummy worms. And I'm like, I'm full. Why am I eating these gummy worms? But I always seem to have room for, junk foods or candies or popcorn or something like that, no matter how full I am.
Yeah, I think there's a couple different things that play into that. One of them is the sensory-specific satiety, but the other one is just the seductiveness of that food. So, candy has things in it that the brain really likes. And so even if you're full, even if you don't need calories, even if your brain knows you don't need calories, your brain's still like, oh, this has stuff in it that I really like. And it's in a really high concentration, so I'm going to motivate you to eat that. And so this is the sensory-specific satiety is part of the explanation, but also the seductiveness of that food. I mean, this is why we have a second stomach for dessert. If you're at the end of a big meal, you do not need any more calories. You probably already feel stuffed. But when that dessert menu comes around, or the slice of cake or the brownie or whatever it is lands in front of you, all of a sudden you're ready to eat hundreds more calories, even though you're stuffed. I mean, that's how powerful these systems are.
Mm-hmm. Yeah, and that's me, because I was like, I kept asking myself, like, why am I sitting here eating? And I know that I'm full, but I don't know. It was something about those gummy worms that I had to have. One of the things I wanted to ask you about the brain is the hypothalamus, because it seems like the hypothalamus, there's a lot that goes on with the brain from reading your book, but it seems like the hypothalamus was one of those important things. Talk about the hypothalamus and what it actually does.
Yeah, absolutely. So a lot of people don't realize this, but the brain actually regulates body fatness. And this has been known for a long time. The first inklings of it were published back in 1840, I think, by a German professor named Bernard Mohr. He published on a woman who had a tumor in her brain, in this part of the brain, the hypothalamus, that had damaged her brain and caused her to develop extreme obesity in a fairly short period of time. And this is called hypothalamic obesity. It still happens regularly today. Not that it's common, but you still see it in clinical practice. And yeah, so it turns out that this is just a really important part of the brain for regulating a lot of different things. The hypothalamus regulates your body temperature, it regulates your blood pressure, it regulates a lot of different things in your body. And one of those things is your body fatness, also regulates your blood glucose. And the way it works is that your fat tissue produces a hormone called leptin that enters your circulation and is present in your circulation in proportion to the amount of fat that you're carrying. So the more fat you have, the more levels of leptin you have in your blood. And your brain basically uses that to measure the amount of fat you have in your body. So that's a signal to your brain of what your fat stores are. And so just like your thermostat in your house measures temperature and uses that to regulate heat and cooling to maintain the stability of temperature, your brain uses leptin to measure your body fatness and uses things like hunger and food cravings and physiological things too to regulate, to maintain the stability of your body fat stores. So your brain is basically trying to keep your body fat level stable. And so this is why some people who are lean just don't seem to gain weight. And it's also why people who have obesity have a really hard time losing weight, because their brains are actually defending that higher level of body fatness. Otherwise, I mean, if there was no opposition from the brain, weight loss would be easy. You could just eat less and you'd be fine. But that's not how it works. You eat less and you get hungrier. You eat less and you get cravings, and you have to fight that day after day after day. And eventually most people give in, and then they go back to their previous weight. So you have this regulatory loop via this hormone called leptin. And I want to be really clear here that there's so much confusion in the popular health and nutrition world about what determines body fatness and what regulates body fatness. I can tell you that there's not this confusion in the scientific community. Leptin is the most important known regulator of body fatness, period. There's huge amount of evidence supporting that. And a lot of people don't know that. A lot of people have never even heard of leptin. I think this is a testament to how poorly this scientific information is communicated with the public. Anyway, so that's kind of how it works. And that's why weight loss is so difficult. That's why you get this response that makes you hungry, that makes you sluggish, etc. And the reason we know that's due to leptin is because experiments by Rudy Leibel and Michael Rosenbaum have shown that if you get someone to lose weight, but you give them leptin injections so that their leptin doesn't drop in response to that weight loss, so you're just maintaining their leptin level so it doesn't drop, you see that pretty much eliminates the hunger response. It eliminates the reduction in metabolic rate. It eliminates the brain's reactions to food cues, the excessive reactions to food cues. So it basically, leptin, that drop in leptin that happens when you lose weight, that is pretty much the reason why all of these things happen that fight back against you and undermine your effort and cause you to gain weight. And so that's really the importance of the hypothalamus. It's the brain region that's receiving that signal of leptin. It's the brain region that's watching out for any decline in leptin. It's the brain region that is generating this starvation response, basically is what it is, via changes to your hunger and your cravings and your metabolic rate, etc. So the hypothalamus is kind of sitting in the driver's seat, and it has all these levers it can pull to maintain the stability of your body fatness. And when it sees your body fat's dropping, it starts pulling those levers.
When I was a kid, I could not gain weight. I was a tall, skinny kid. And as I aged to 25 years old, I started picking up more weight to my present weight. I'm not overweight by any standard now, but is that solely metabolism, or can we attribute that to maybe changes that are going on within the brain? Because you see that in our society where a lot of people, when they're young, they're slim and trim, but as they get older, they start gaining weight. And then you see as they get into like elderly, you see a lot of elderly people who are kind of feeble. They've lost a lot of weight, and then they deteriorate from there. So is there something going on with the brain with something like that?
Yeah, absolutely. There clearly is. So, and I think this is a really important segue into this next topic, which is that this set point, as I like to call it, around which the brain regulates your body fatness can change. So it's not like one thing, it's not this like one value of, your brain wants a certain number of pounds of fat on your body and it's going to defend that no matter how old you are. It can change over time depending on your circumstances, your diet and lifestyle, your age, whether you've gone through menopause. All these things can affect it. And we know that if you just take a person living their normal life who's lean, their brain is defending the level of body fatness that they're currently at. If you take a person with obesity, their brain is defending the level of body fatness that they're currently at. But if you caught them before they had obesity, their brain was defending that level. So obviously the level is changing over the course of our lives. And so the question is, why does it change? And we don't really have definitive answers there. I can say in broad strokes that in animal models, when you give them calorie-dense, refined, highly palatable foods, they will gain weight rapidly and they will develop resistance to that leptin hormone, and their set point will go up. They will become obese, and then they will start defending that obese level against weight loss. And so in really broad strokes, we know that the kind of food that we, intuitively view as unhealthy, junk foods like brownies and pizza and ice cream and fries and all that delicious stuff, that is the kind of food that makes it happen. We don't know exactly how it happens or what the specific food components are. But I can tell you it's not just, some people think it's all about sugar. It's not just about sugar. It's not just about carbohydrate. It's not just about fat, although fat seems to be a key component. And so it seems to be something about this, the whole picture of that food. And we don't know exactly what it is that's what the mechanism is exactly. But I do want to note that physical activity also plays into it. So if you give animals a wide variety of human junk foods, they will get super fat really fast. Human junk food is not only fattening to humans, it's extremely fattening to animals. But if you have them exercise regularly and vigorously, that will attenuate the fat gain quite a bit. So it doesn't completely prevent the fat gain, but it does make them less obese than they would have been by quite a bit. So I view exercise as an important preventative measure, even though it can't completely prevent it. It can't completely wipe out a bad diet, and it can't necessarily erase all the damage that you've already done. But I think particularly in a preventative context, it is really important. And I think for someone like you or for someone like me, we can't, neither one of us can really know exactly why we're lean. There's probably a lot of things going into it, genetics and lifestyle and diet. But I mean, certainly it would be reasonable to speculate that consistent, regular, and vigorous physical activity is an important part of the reason probably why you and I are lean.
Last segment of the show, I just want to get into some solutions, because I know a lot of times we listen to these podcasts and maybe we don't get the solutions, but how can you outsmart the brain for those people out there who are looking for some solutions to losing weight? They piled on a lot of pounds. Some of them been overweight for most of their life. What would you suggest in really outsmarting the brain, if so to speak, to say, hey, you know what? I know that I have these things that are going against me. The brain is actually seeking out calories for me to eat, but how can I trick the brain, so to speak, so I can finally shed some of these pounds?
Yeah. So I think, as you alluded to, the first thing you want to do is just accept that we have these circuits in our brains that are pushing us to eat too much. It's not your fault that they're there. It's just something that we're hardwired with through the course of our evolution. We have these urges that our brain creates. It's not, something you need to blame yourself about, but it is something you need to understand and try to work with. And so there's a couple things that, there are a number of things that you can do that I outline in my book from the perspective of trying to work with these circuits and trying to understand with them and try to actually recruit them to help you instead of having to fight you all the time. But I'll just talk about a couple of them that I think are particularly important. One of them is to control your food environment. So as I was saying earlier in the show, we have these certain foods release a lot of dopamine, and then that stamps these cues into your brain as triggers for your motivation and your craving. So when you see a bag of chips, or you smell the brownies, or you see the ice cream, or even just the ice cream's in the freezer, those are motivational triggers. You're telling your brain, this is a situation in which I can get this really awesome food. And that's going to trigger a motivational state in you that can be very persuasive, as most of us, including me, know quite well. And so you want to prevent that from happening. You don't want to give your brain those sensory triggers that causes it to initiate that craving. And the way you do that is by controlling your environment. You eliminate those cues, or at least reduce them to a reasonable level that's more consistent with your goals for yourself. And so you don't want to have tempting, visible foods in your living space, even in the kitchen. You want to be able to walk through your house and walk through the kitchen without seeing any foods that you don't want to be eating. So things like chips and soda or snacks, candy, all of that stuff, I'm best to get rid of it out of the house. But at a minimum, put it somewhere where you can't see it. Put it somewhere where you have to work a little bit to get to it, like maybe a really tall cabinet inside a screw top jar. But better to just get rid of those things. So if you walk into my kitchen, just to use myself as an example, what you're going to see is the only food that you could just grab and eat is fruit and peanuts in shells, unsalted peanuts in shells. So, I like peanuts. Peanuts are good, but these peanuts don't have any salt on them, and I have to break the shells to eat them. So I've created an effort barrier for myself, and I've presented the food to myself in a way where it's not that tempting. And same for the fruit. Like, I often have oranges. Oranges are something where, yeah, I like oranges, but I don't like it as much as pizza or brownies. I won't eat it if I'm not full. And furthermore, I have to work for it. I have to peel that orange. And so having effort barriers and controlling your food cue exposure to only foods that are not that tempting, healthy and satisfying, but not overly tempting, that allows you to not have cravings that drive you to eat when you're not hungry and when you don't need calories. So you can accurately match your calorie intake to your true needs, and you're not going to be constantly eating food that you don't need to eat. And I want to say that when you get rid of foods out of your house, not only does that just physically make it harder for you to eat them, but you will actually crave them less, because when your brain knows that there's no reasonable possibility for you to get a particular food, it will actually not even generate that craving. That's how cravings work. They happen in situations where your brain thinks it can get something easily. So, like if you're trying to quit cigarettes, seeing a pack of cigarettes on the counter or being around someone who smokes, those are the triggers that trigger your craving. Similarly with food, if there's not any food in the house, you're probably not going to experience that craving, or at least not to the same degree as you would if it was on your counter or even just in your fridge or freezer. So that's one thing. Controlling your food environment at home and at work, I think, is really, really critical. And then another thing I'll say is, and just by the way, just to clarify, the brain system that is relevant there, that has to do with the basal ganglia, which I talk about in my book, which is that system that generates those motivational states and those cravings. So you're basically not giving that system the triggers that get it fired up and lead to difficult to control unhealthy eating behaviors. So the second thing I want to talk about is the brainstem, which is the part of your brain that generates the feeling of satiety or fullness at a meal. So basically the way this works is when you eat food, there are receptors in your digestive tract that measure all sorts of properties of that food. So it's measuring the amount of protein, it's measuring the volume, it's measuring the carbohydrate, and all sorts of things. All that stuff goes up to the brain, and it gets integrated in a part of the brain called the brainstem, which takes all of that really complicated information and puts it together into one signal, and that's your satiety signal. And that gets broadcast to the rest of the brain, and eventually, with each bite, it builds. And then when you've had enough, when your brainstem thinks you've had enough, it broadcasts that to the rest of your brain, and that shuts down your motivational drive to eat. It shuts down the pleasure you're experiencing for that food, and your meal is over. But it turns out that you can actually use this system to your advantage because it responds more to some types of calories than others. So you can actually select certain types of foods that will make you feel more full while containing fewer calories. And we know that foods that have a lower calorie density, that is to say, foods that contain fewer calories per volume or per weight, are more filling per calorie. So, for example, if you had a bowl of oatmeal, that is more filling than an equivalent number of calories of crackers that contains a lot less volume because it doesn't have as much water or fiber. So, okay. And then that applies to a wide variety of different things. Another thing is palatability, or the pleasure value of food. So the more enjoyable a food is, the less filling it is per calorie. So if you're eating ice cream or pizza or whatever your favorite food is, you can eat that. You can eat more of it. You have to eat more of it to reach the point of satisfaction. Another one is fiber. So higher fiber foods are more filling per calorie. And then protein. Protein is more filling per calorie. So basically, if you think about the opposite of what I just said, if you think about foods that are calorie dense, that have low fiber, that are highly palatable, often have low protein, but not always, you're talking about junk food. I mean, that really describes the types of foods that we intuitively recognize as unhealthy and fattening. Things like candy and deep fried food and sweet, fat, baked goods and things like that all fall into that category. Conversely, when you look at foods that are lower in calorie density, lower or moderate in palatability, higher in fiber and protein, you're talking about whole foods that we intuitively recognize as healthy. You're talking about vegetables and fruits and fresh meats and eggs and yogurt, stuff like that, oatmeal, whole grains. Those are the types of foods that are more similar to what our ancestors ate, more unrefined foods, and foods that are going to trigger satiety more effectively per unit calorie, so that when you hit that point where at the meal where you say, hey, I've had enough, I feel full, I'm going to stop eating, you naturally have consumed fewer calories than if you're eating those other types of foods.
Mm-hmm. Yeah, so you're saying basically to just get away from the junk food and just eat more whole foods. Just eat more what we would call real food.
Yeah, I think that, if I could sum my food advice up really simply, I would say eat unrefined, lower calorie density foods, and that will get you much of the way there.
Stephen, I've kept you over by about 6 minutes. Maybe when I edit this show, that 6 minutes will be gone, but I thoroughly enjoyed the discussion. I thoroughly enjoyed your book. A lot of great research in there, a lot of great research examples. So if the audience out there, you're listening, you want to pick the book up, you can pick it up on Amazon. I don't know if you have a website. Do you?
Yeah, I have a website. It's at stephanguyenet.org, or if you don't want to have to spell that, you can do wholehealthsource.org.
Stephan, thank you so much for being on Perfectly Healthy and Toned Radio.
All right. Thank you, Darren.
Yo, can I park here?
Let me see. Smith Street, sign says 15 minutes between Friday and Tuesday. Yeah, it's probably fine.
Good. I'm just going to the AT&T store. There's a deal that's New York only. I'll run in and run out.
You didn't take the F?
Yo, you gonna park here?
Yeah, he's going to the AT&T store. They got a deal just for New York.
You didn't take the F?
Hey, New York, come into an AT&T store and find out how to get a smartphone for free. AT&T, more for your bargain hunter thing. That's our thing. Limited New York offer. See store for details.
Yo, can I park here?
Let me see. Smith Street, sign says 15 minutes between Friday and Tuesday. Yeah, it's probably fine.
Good. I'm just going to the AT&T store. There's a deal that's New York only. I'll run in and run out.
You didn't take the F?
Yo, you gonna park here?
Yeah, he's going to the AT&T store. They got a deal just for New York.
You didn't take the F?
Hey, New York, come into an AT&T store and find out how to get a smartphone for free. AT&T, more for your bargain hunter thing. That's our thing. Limited New York offer. See store for details.